Okay, so we're now up to the last bit of the vectors, and vectors in 3 dimensions is what we are looking at. And so what we do is we add the 3rd dimension, because of course, as we know in real world, we live in 3 dimensions, not 2. And so we add a 3rd axis, and that axis we call the z-axis. So what we do is, instead of the paper being the X and Y, what we do is we rotate the X, so the oh, I haven't labeled that properly. Is that we just notice I've made a mistake there. So let me fix up my mistake. So what we do is we rotate our axes so that the x-axis is pointing out of the page, and I've got Z there, that should be the x-axis, and the z-axis up the page and the y to the right. So now I've got those 2 vectors labelled incorrectly. Let me fix that up. So in the x direction, so that there should be I, vector I, and this here should be vector k, so in the z direction. All right, because that's kind of the standard. So x out of the page, y to the right, and z up the page, and I and j for the x and the y bits, and k there for the z bits. So we use these unit vectors I, j, and k. So very, very similar to what we did before when we worked in 2 dimensions. All right, so we just add this other component, this k component in the z direction. So the position vector, and I've got this one labelled correctly. So the position vector for the point A, which is x, y, z, and so here's our point A all the way out here. And so the position vector goes from the origin straight out to there. So it's gone a bit in the x direction, a bit in the y direction, and a bit in the z direction. All right, and so if you then use Pythagoras and you do it twice, you get the magnitude of that vector. That distance from A to A is x squared plus y squared plus z squared. Again, very similar to what we had with just 2 dimensions, I and j. All right, so let's get into some examples. Here's an example. So we've got 2 vectors, A and B, and it says here that our vectors A and B, yep, there we go, that over here. A is vector I plus j minus k, and vector B is I plus 7k. No no j component, that's all right. So what do we do when we add them up? Well, same as we did in 2 dimensions. So vector A plus vector B is I plus j minus k, and to that we're going to add I plus 7k. So you look at your components, you've got I component, so we've got 2 lots of them. J, there's only this j here, plus j. And then we've got minus 1k there and plus 7k's there, so that would be plus 6k for that. All right, so vector B, part B is vector B minus 3 lots of vector A. And so vector B is I plus 7k minus 3 lots of vector A, which is I plus j minus k. And so if you like, we can go, I'm going to expand that bracket, I plus 7k minus 3 lots of I minus 3 lots of j and plus 3 lots of k. Alright, positive and positive. A negative times a negative, I should say, is a positive. Alright, add our components. The i's, we've got 1 there and minus 3, so negative 2 overall. The j's, just that negative 3 lots of j. And we've got plus 7 plus another 3, so that's plus 10 lots of k. Alright. So that's that. Alright, so the next part says what's the magnitude of A? So the magnitude of A, to get that, we simply need the square root of the components, just the x, so the x squared, the y, and the j, and the k, in the j direction, of course. And so you just look at that, and that's 1, 1, and minus 1. So you got 1 squared plus 1 squared plus negative 1 squared, which I believe would be then the square root of 3. So for the unit vector A hat, well, the same as we did when we did in 2 dimensions. The unit vector A hat is simply our vector A over the magnitude of vector A. And there's a few different ways you can express that. And one of them is 1 on root 3 times vector A, which is not x, but I, plus j minus k. And other options, of course, could be I plus j minus k, all on root 3. Alright, so there's how we deal with those. As I said, really not much different at all to what we did in 2 dimensions. We can also solve geometric problems in 3 dimensions. Again, we just add that. So here we've got this thing, cuboid, just a box, rectangular box, rectangular prism, cuboid, all mean the same. So we've got O, A, B, C, D, E, F, and G are all the corners, the vertexes. All right, and we're given, so OA is 3J. So OA is therefore, as I put there, that note pointing to the right. OC is K, so that means that's up the page. And OD is equal to I, which means that's out of the page. So when I have drawn this, that's why I've put O at the back here. All right, because OA has to point to the right. So O's got to be over the left to point to the right. OC, that points up the page, so it's got to go up. So, and then OD is I, which is therefore got to be out of the page. So then puts the O down here, A across here, C up there, D out here, and then I've just filled in. So B over there, and then D, E, F, G. All right, now I've already added some extra things in, so which comes to part B, so just ignore it in a moment, the red. All right, so we express the following in terms of I, J, and K. Forgot my little vector sign there. All right, so let's have a look. So the first one is part 1 is asking us from O to E. All right, so O to E, that's over here. So there's a couple of different ways we can go. I can go from O to A and then to E. So I'll do that. So we'll go from O to A and then to E. Like so. And so then O to A, that's the 3J. And then A to E. Now, because this is a cuboid, rectangular box, that means that these sides here, AE and OD, are not only the same length, but they are parallel. So if I is pointing, OD is I, then AE is also I. All right, so because it's a cuboid, so we know a bunch of stuff because it's a cuboid. All right, part 2 of this is O to F that we want. All right, so O to F, where is F? All the way over here. So we can go from O to A to E to F. There's other ways of getting there, of course. So we go from O to A to E and then up from E to F. Now, O to A to E, well, we've already figured that out up the top. So that's 3I plus 3J plus I, not 3I plus J. So let me put it in alphabetical order because that's a bit nicer. So I plus 3J. And then E to F. Now, E to F is this edge that's up. Now, this edge that's up is the same length, but also points in the same direction as all of these edges that are up because it's a cuboid. So that there is parallel to and the same length. So E to F is parallel to and same length as OC. And so that's plus K. All right. Next one, G to F. All right, so now we're just going from here to here. From G to F. Now what we need to do is we need to have a look. Well, it's just straight. Bang, straight across there. So what edge is that parallel to? Well, it's parallel to this one here, and this one here. Because again, it's a cuboid. One we're interested in is O to A, so because it's parallel, points in the same direction, same length as O to A, then it's the same as vector O to A, which is 3J. All right. Then the next one is G to B. So now we're going from here all the way over to there. There's a couple of different ways we can get there. So G to B. So G to B. We can go to G to F. I'm going to do that because we've just done that one. And then F to B. All right, G to F, F to B. All right, so we found G to F before. Now this F to B, that edge is parallel to all of these. So it's the O to D bit that we're interested in here. Now, directional, of course, we're going from F to B. We've got to go from G to F and then F to B. Now going from F to B is the opposite direction. Well, it's the same direction as going D to O, which is the opposite direction, O to D. So of course with vectors, we put them as opposites. So we got 3J, and the opposite is minus in terms of vectors, O to D, which is I. And so there is our vector GB in terms of I and J. All right, one last part here. M and N are the midpoints of O, D, and G. F, find M to N. All right, so this in the red, I've done in red, that dot there, M, halfway. And this N here, halfway. So let's have a think. M to N, how can we get there? We can go from M to D to G to N. So let's write that down. Let me change this thing. All right, we're going from M to N. That's what it'll be. Does that all the time. B, M to N. So what did I say? That's from M to D. And then from D to G, M to D to G. And then from G, we go to N. Now, M to D, because they're both midpoints, remember, so that's a midpoint, that's half of O to D. So that's a half of O to D plus D to G. And this one here, because that's a midpoint, that's a half of G to, let me just check the F. G to F. All right, and half of O to D is half of I. D to G. D to G, his point is that edge is parallel to the O to C edge, so it's parallel, same length, so that's K. And the halfway G to F, there it is up here. It's a half of 3J. So if you like, you can neaten all of that up and say that's a half I plus 3 on 2J plus K. And there it is. All right, so again, not overly different to two dimensions. It's a little bit more complicated, but work in the I, the J's, the K's, draw your diagrams, see what you got, see what you need, and work from there. All right, so if there's anything there that you're not sure about and you need help with, make sure you get some help. And as always, have fun.